Hello everyone, welcome back to my channel. Here in my browser, I'm showing you a certain page from the book Building Microservices, titled Microservice at a Glance. And I will be using also the Microsoft Copilot to understand better some concept. Microservices are independent releasable service that are modeled around a business domain. So the sentence says microservice is an independent releasable service. Releasable service, it is, in my understanding, it is a kind of service that you can release to production independently. I'm not sure if I structure my sentence correctly, but let's ask a help from Copilot. Independent releasable service refers to component or module within the software system. So there is a much larger software system. Independent releasable is a component or module within a software system that can be developed, tested, deployed, and updated independently of other services. This concept is often associated with microservices architecture. Yeah, this is exactly what I'm reading here, where each service is designed to perform a specific function and can operate autonomously. What do you mean by autonomously? What is autonomously? So those are the key points here. It is a component or module that can be developed, tested, and deployed and updated independently. So that means it is also a software where if you make a changes, it will not affect other parts of the much larger system. Key point, modular, yeah, I mentioned here. Independently releasable services, modularity. Another question of this one is later. Modularity. Each service is self-contained unit of its own code base, database, and dependencies. It has code base, database, and dependencies. So it is microservice can be considered as simple app. Let's ask. So microservice can be considered as simple application. No, I think there you can call microservice if it fits this modeled around business domain. So if a software that has, or if a software that is a self-contained with its own code base, database, and dependencies, you cannot directly say that it is a microservice. You can say that it is a microservice if that simple system is modeled around in a business domain. So if the business domain is using that service so that the much larger system can function as a large system, then we can call it microservice. That's what I understand. Loose coupling. Services interact with each other through well-defined APIs, minimizing dependencies and allowing for independent change. Loose coupling. Services interact with each other through well-defined APIs. Yeah. Application programming interface. Minimizing dependencies, I think dependencies on other services or functionalities. From what I understand reading this is that it can stand even other services are not functional or something like it's been turned off. Scalability. Services can be scaled independently, yeah, based on their specific needs. Yeah, it's because it has its own code base, database, and dependencies. Improving resource utilization. Continuous deployment teams. So you can also have a dedicated team that will work on that specific microservice. Can deploy updates to individual services without affecting the entire system, enabling faster and more frequent releases. Fault isolation. Issues in one service do not necessarily impact other services, enhancing system reliability. Technology diversity. Different services can use different terminologies and programming language, allowing teams to choose the best tools for each task. This approach can lead to more agile and resilient software systems. If you have any specific questions, yeah, sorry. So does it require, I'm going to ask, does it require independent server? Let's ask that. So let's continue. So from what I understand reading this, microservices are independently releasable. That means, let's go back. It refers to a component. So independent releasable service refers to a component or module within the software system that can be developed. I'm thinking earlier, releasable service, a service that can independently release to production, but there's more. That can be developed, tested, deployed, and updated independently from other services. Okay, so let's take note of that. Developed, tested, deployed, and updated independently from other services that are modeled around business domain. Business within So that means microservices, if you install it or put it in other systems outside this business domain, it will run, but it will not suitable, or I cannot explain in simple term, but let's ask what will happen if a microservices is being put in other system outside business domain it's intended. If a microservice is deployed in a system outside its intended business domain, misalignment with business logic may not align, leading to incorrect or unexpected behavior. Data incompatibility. The data structures and format used by the microservice might not match those of the new system, causing data integration problems. Security risks. So it simply doesn't fit when we install microservice in other business domain. Performance maintenance challenge. Autonomously means acting independently. Why did I ask autonomously again? And can operate autonomously. The microservice can operate autonomously, meaning acting independently or having a freedom to do so. In the context of microservice, it means that each service operates independently and can perform its function without relying on other services. It is like an app within if this is the mobile, microservices are just like application installed in the mobile and they can operate independently. But application in a mobile, we cannot call it microservice because those apps, most of them do not interact with each other via networks. So those are just services, not microservices, in my understanding. A simple application, but they are part of a larger system. So if they are not part of a larger system, then they are simply service. Each microservice is designed to handle specific business function and can be developed, deployed, and scaled independently. Regarding the need for an independent server, microservices do not necessarily require separate physical servers. They can be deployed on the same server or across multiple servers, depending on the architecture and requirements. The key is that each microservice runs in its own process and communicates with other services through APIs. So a service, back here in the page, there are much more reading on the Copilot than here in the book page. A service encapsulates functionality and make it accessible to other service by a network like I mentioned earlier. You construct a more complex system from these building blocks. One service might represent inventory. So it should be at the level of this kind of service. So if you just write a functionality, it cannot be called. So when you have code base, So when you're looking at some code base, how will you determine that it's a microservices? So if you see some class or function, you cannot determine it as a microservice. It should have some architecture in it. I think it just repeat what is written above. It's with its own repository, directory structure. It has its own repository, Git repository, and directory structure. Independent deployment, yeah, as discussed earlier. API, so it has repository and directory structure. It has API communication, database per service, technology diversity. Let's discuss about service discovery. There are mechanisms in place for service to discover and communicate with each other, such as service registries. But I think this will be handled by the larger system. It might be a separate service that handle the registries, configuration management. So it really acts as an application, scalability, fault isolation, monitoring. Okay, so that's why it says here, one service might represent inventory, another order management, and yet another shipping, but together they might constitute an entire e-commerce system. E-commerce system. Microservices are an architecture choice that is focused on giving you many options for solving the problems you might face. They are a type of service-oriented architecture. So if the code base doesn't have an architecture, does not count as microservice. Albeit one that is opinionated about how service boundaries should be drawn. Service-oriented. So if you are developing an application within a business domain that is service-oriented architecture, then that is microservice. And one in which independent deployability is key. There are technologies agnostic. They are technology agnostic, which is one of the advantages they offer. From the outside, a single microservice is treated as a black box. What do you mean outside? Outside business domain? It hosts business functionality on one or more network endpoints. It hosts business functionality on one or more network endpoints. My understanding about endpoints is URL, but let's ask, what is network? Specific points in the network where communication occurs. So just like URL, it represents, I think the right word there is specific to the URL. No, specific. Sorry. They can be devices, servers, or application that sends or receive data. So it's not URL. In the context of microservices, endpoints are the URLs. So I'm right. I am right. URLs or IP addresses through which services communicates with each other. Okay, so URL, I'm right with my understanding, but I know that there's a deeper. But in the URL, that's the endpoints that the two system establish communication. So one or more network endpoints, one or more URL. Example, a queue. Okay, yeah. When you queue, you are establishing a form of communication there, or a REST API as shown in, I don't know where is that, over whatever protocols are most appropriate. Consumers, whether they're other microservices or other sorts of programs, access this functionality via these network endpoints. Wait, from the outside, a single microservice is treated as a black box. Black box? What do you mean by treated as a black box? Explain. As a black box. When something is treated as a black box, it means that its internal working are hidden or unknown, and it's only its inputs and outputs are considered. As similar to the, I don't know, there is something in my mind about the circuits, but I can't describe, like capacitor, diode. The term is often used in engineering, computing, and systems designed to describe a component or system where focus is on what it does rather than how it does. For example, in software development, a function or module might be treated as a black box. A function, developers know what inputs it requires and what outputs it produces, but they don't need to understand the internal code or logic that makes it work. Yeah. This approach can simplify development and maintenance by allowing developers to use and integrate components without needing to delve into their complexities. Okay. So I understand now. A single microservice is just like that. A developer just use the service where without needing to delve into their complexities. You can just use endpoints over whatever protocols are most appropriate. Consumers, whether they're other microservice or other sorts of program, access this functionality via these network endpoints. Internal implementation details, for example, like technology the service is written in or the way data is stored, are entirely hidden from the outside world. This means microservice architectures avoid the use of shared databases in most circumstances. Instead, each microservice encapsulates its own database per required. Yeah, just like it mentioned here in the copilot. Queue network endpoint. When the consumer queue something here, then this point establish a form of communication. Endpoint, network endpoint. Order management, REST API, exposing its functionalities over REST API and queue. It exposed the functionality through REST API that can be consumed by the consumers or exposed through queuing consumed by the consumers. Microservices embrace the concept of information hiding. Information hiding describes hiding as much information as possible inside component and exposing a little as possible via external interface. External interface, that is through the use of interface. External and explain external interface. I think this is the point where the two application communicates. Refers to the points of interaction, interaction between a system and external entities. So these are the points of communication, such as other system user or devices. This interface define how data and commands are exchanged effectively, ensuring that the system can communicate effectively with the outside world. Application programming interface, user interface, network interface. Application programming interface, these are the set of rules that allows other service how they can communicate. Hardware and software companies enable to connect system to connect and communicate over the network. These define how data exchange between systems. So that's an interface. So information hiding describes hiding information as possible inside a component. Okay, hide the information as possible inside the component and exposing a little as possible via external interface. This allows for clear separation between what can change easily, and what is more difficult to change. Implementation that is hidden from external parties can be changed freely as long as the network interface, the microservice it poses, don't change the backward incompatible fashion. Implementation hidden from external parties can be changed freely as long as the network interface hidden from external parties can be changed freely as long as the network interface the microservice exposes don't change. As long as the network interfaces the microservice exposes don't change in a backward incompatible fashion. Don't change in a backward incompatible fashion. Network interfaces in microservice. I don't quite understand, although clarify this. There's one. This means that the internal workings or details of the microservice is not visible yet, just like only microservice itself knows how it performs its task. Change freely. Since the internal details are hidden, developers can modify or update the internal implementation without affecting other systems hidden from external parties. Implementation that is hidden from external parties can be changed freely as long as the network interface. Okay. So as long as the, like for example, the URL is not changed, that means that that service can still communicate with other services. So the developers can free change the inside of the microservice as long as the final output result of the changes still communicates with other services. Network interface. These are the endpoints and these are the points, not endpoints, of interaction. Backward incompatible fashion. This means making changes that would break or disrupt existing interaction with other systems that rely on microservice. Okay. Okay. Changes inside microservice boundary shouldn't affect the upstream consumer, enabling independent releasability of functionality. This is essential in allowing our microservice to be worked on in isolation and release on demand. Having clear, stable service boundaries that don't change when the internal implementation changes result in systems that have looser coupling and stronger cohesion. Stable service boundaries that don't change when internal implementation changes. Tama. Yeah. Result. So in the next video, let's understand the key concept of the microservices. So if you are someone who are still listening to me until now, thank you, and I hope you also learn from this microservices. So see you in the next video.